Good morning, this is your Stat Sensei, Mr. Sensei, and this is a warm-up for an intro to hypothesis testing, and this is Bozeman water, which is in your notes spiral. We are going to assume that you've gone through the confidence interval, and we're going to use knowledge of that, what we know about a confidence interval, to help get us started on this. So, the amount of water consumed per day by Montana residents is normally distributed. Sorry about that, with a mean of 125 and a standard deviation of 10. The city of Bozeman claimed that the average water in Bozeman is less than the state. That's going to be important later. A simple random sample of 11 residences. So we have a sample size of 11, found an average of 120.3. So X bar equals 120.3, and there are more than 14,000. It says define the parameter of interest, check the conditions, and calculate the probability of having a sample mean of 120.3 given a population mean of 125. So, first off, what do we have? Well, we know our population mean is 125. We know our sample standard deviation is 120.3. We know the population standard deviation is 10. And we had a sample size of 11. All right. My basic formula for this is going to be Z equals X bar minus mu, the standard deviation divided by the square root of N. That was in our previous probability unit. All right. So when there's a whole lot of this we don't know how to do yet, we'll learn how to do that in the notes. But for right now, let's continue on. And it says they want us to define the parameter of interest. Well, we know how to do that because we did that with our confidence interval. So our parameter of interest is let mu equal the true population mean amount of water consumed. All right. So we know how to do that. The next thing we know how to do is, well, the next thing it asks us to do is calculate the probability, check the conditions. All right. So it says right here, check the conditions. Well, they told us we have a random sample of 11. So that's our first condition, randomness, random sample of 11. And that was given. 2, we're going to take 11 and multiply it by 10. Remember, we're always multiplying by 10. That equals 110. And that's less than, they told us our population size was 14,000. So N is less than 10% of the population. And the condition I consider most important is the normality condition. Well, in this case, they were really, really nice to us, and they told it it's normally distributed. So we get to just say normal. Why is it normal? How do we know? It was given. So that makes it the very easiest thing. Okay, the next part. This is going to go back a ways. Calculate the probability. Well, we said Z equals X bar minus mu, standard deviation of the population divided by square root of N. Well, we have all that information, so let's go to the calculator and do a Z test. So we're going to go to z-test, stat, test, z-test, highlight the word stats, and we're going to have a mean of 125, a standard deviation of 10, a sample mean of 120.3, and N in this case was 11. And they said, hey, we wanted to see if it were um, less than the state. So we need to have a less than symbol. And when we do that, we get all this information, and this is what we're interested in. And I'll help you place it in our notes in just a second. The probability that Z is less than negative 1.5588 equals our p-value 0.0595. So placing that, where does that go in our in the note spiral? Well, we're going to go back to our probability statement and say the probability that Z is less than negative 1.5588 equals 0.0595. All right, and we're also going to go ahead, even though it told us not to, we're going to go ahead and plug this in. And we're going to plug the information in, and we're going to go, oh, if that's our formula, we can go Z equals 120.3 minus 125, sample mean minus population mean divided by standard deviation of the population divided by the square root of 11. And lastly, we're going to draw a picture. Well, confidence intervals were centered on X bar. Hypothesis tests are centered on the mean. So this is going to be centered on 125. They told us they wanted to test to see if it was less. So we're going to be looking for less than, and we happen to have right here an X bar of 120.3. And this technically goes to negative infinity. All right. The rest of this information we'll cover in the notes, but these are things that we learned in our previous sections, either in the probability section or when we were doing confidence intervals. Appreciate you watching, and I hope to see you on the next one. Thank you.